invited speaker will be Dr. Muhamad Reza from Solvina International, and he will give a presentation about disruptive innovation, electricity 4.0. Dr. Reza, the floor is yours.
Okay, thank you very much. So I think it's a good continuation from Professor's presentations about innovation. Today I'm going to talk about innovation in electricity. We started from 100 years ago actually when electricity came out. It was a disruptive innovation. Maybe some of you remember, I don't know, last time you remember use the oil lamp compared with electricity. Maybe we were not that realizing the disruption of this electricity, but in the beginning, when electricity was being used, actually even in hotel room, people have to place an announcement like this, so people will not try to light up the light with matches. So it's actually to show that electricity was indeed disruptive innovation when it came out. So early technology, electricity was developed by direct current technology, DC current, or AC current technology. DC at the time started in 1882, serving only about 80 customers for 100 lamps, and started as a company led by Thomas Alva Edison. The alternating current in 1885 was in Italy for public lighting. So, actually, it was not mentioned as electricity 1.0 at the time, but we could, at this point now, we could actually recognize this as a first generation of electricity business. So it was identified as a small power plant, which was localized and small scale, operating island, so it means isolated from other systems, and the small power plants supply electricity to residential mostly. So basically to household around the company. That was the first disruption, and then came the second disruption. It was what was so-called the current war, when alternating current was competing against direct current, DC current. At the time, in the early stage of electricity development, there was two technologies, DC and AC, and it was a competition between these two, which one would be the standard of electricity development in the future. And history told us that alternating current survived the competitions at the time in the 1890s. And one of the reasons was actually because at the time, there was also another disruptive component, which is the transformer. Which is a transformer which used to basically convert the voltage level of electricity from one voltage level to the other voltage levels. And with this quote-unquote practical voltage conversion, the impact is huge, because then it's becoming easier to transmit electricity in long distance. First of all, we can generate electricity with power plants in a more economic way, so it's becoming more lower in cost to generate electricity per kilowatt hours, and it's becoming more efficient to transmit in long distance, in high power, and again, it's practically more safe to consume in households, simply because we can step up or step down the voltages. So this alternating current makes then the electricity system interconnect one to another, because here we see the benefit of interconnecting different power plants into one big transmission system, as we can utilize these power plants for efficiently. And as the result, what we now can call electricity the second generation, which is basically characterized by big power plant, which usually a monopoly company that cover the whole region, if not the whole country. So as a result, there was like one big interconnected transmission and distribution systems, and a lot of customers, now also residential, business, commercial, and industries, who are connected to the big system that operate large power plants. So customers in this case has no other option than to deal with the big company, because this big company basically control from generation, transmission down to distribution. So control the overall. So as the customers, not much option. If you want to have this electricity, you have to deal with that one company. However, there was a disadvantage simply because, of course, we can, even until today, we can see that the energy source, which is most practical and also has high energy density, is coal. So the first and second generations of electricity was mainly supported by coal power plant, which has the byproducts air pollution, carbon dioxide, and so on, in which when we start seeing, or when we start experiencing the situation where people have to wear masks because of this pollution, then customer or people start to think, well, the second generation of electricity may not be the end, we should go further. And people start protesting. They want to have a clean air to breathe. It's not only in developed countries actually, but also in developed countries. People are protesting against this byproduct of pollution. So what happened here actually when we talk about electricity business, more than 100 years of business, actually there is a barrier, there is a wall between us customers and electricity as a product. Why? Because after the second generation of electricity, we can only deal with a centralized company. So as customer, we can simply say, okay, we want to have a good electricity, cheap electricity, reliable one, very convenient, comfortable, whatever. We can say that we can only deal with this centralized company. But when environment is becoming more and more, concern of the people, then all these customers start protesting to have a green energy. And pressure could be that high that then the centralized companies start thinking, okay, wait, maybe we can do something about it. That is on one side. On the other side, luckily, the technology support is also going in the right direction. If you see wind power, for example, just as an illustration here, the earliest technologies one wind turbine could generate like up to tens of kilowatt in rated power, with the diameters of the wind blades in between 10 and 20 meters. That's in the 80s. So if you see, up to now, this wind turbine technology is going in the direction that is becoming bigger, cheaper, and greener. So today, even in Indonesia, this wind turbine in Sidra, you probably know, in Sulawesi, it is the 2.5 megawatt wind turbine with the blades is, I think, almost 100 meters. Just to put an illustration, it's like the whole length of football field. So this electricity 2.0 is going into the direction 3.0, which is nothing but we have more and more electricity generated from renewable energy sources. And again, most of this electricity generation was handled or is handled by a decentralized company anyway, which is now, it's possible to have these large-scale renewables in terms of wind power and solar power, which is connected to medium voltage or high voltage in the transmission distributions, and they are supplying the consumers. Again, residential, business, and industries. So, this third generation of electricity maybe not yet that popular in Indonesia, but it's starting in many countries, mostly in developed countries. And where will it go further? Actually, to go from one generation to the other generation, there was always something which is disruptive. So from the first generation, electricity was already a disruptive innovation, with this electricity lamp compared to the oil lamp, for example. In the second generation, there was a disruptive component of transformers that made this alternating current won the competitions against the direct current technologies. And then in the third generation's technology supports large-scale renewable energy generations. And what's then in the fourth generation is actually still the renewable energy generations. And many people believe the disruptive technology here is not, in a sense, it's not new because of photovoltaic, but the reduction in price is so much that people start thinking something can be really big out of this. So just an illustration, in the 80s, the cost for one watt peak of photovoltaic was almost $20 US, and today it's already go down to $1 US. And in the next 2-3 years, people forecasted it should be like even 25% cheaper to less than $1 US per watt peak. It was basically beyond what people forecasted some years back, that in 2016 people started believing that as early as 2021, 2022, electricity generation from photovoltaic was already in par with coal power plant per kilowatt hours. So what does it mean? Actually, if we see from customer perspective, now we see that the barrier between customer on the left to electricity on the right is no longer divided via a big wall, because now practically customer can directly access the electricity if they put this photovoltaic on the top of the house or buildings as a result of photovoltaic. So it means like if when they were asking decentralized companies to supply electricity from green sources and the centralized company is not able to fulfill the request from the customers, this customer can theoretically, practically put the photovoltaic on their houses or buildings and generate electricity. So customers have alternatives. And that is what is believed to be the next generation of electricity business, or 4.0. In one sense, because the flow of electricity is no longer in only one way, from power plant via transmission to customers, but now it can be bidirectional. Also from customers, who is now becoming also producers of electricity, they can start supplying electricity to the interconnected system. Will it stop there? The first of all, 4.0, if we may define it, was the bidirectional power. But it may go further to 4.1, when we see that now, actually, at least theoretically, this consumer, which is a producer or prosumers, is not only able to supply electricity to the centralized power plant, but they can actually start selling or buying electricity from their neighbors. If each neighbors or each building has their own power generations. And why it's possible? We heard before about these electric cars. One of the problems of photovoltaics, you know easily that it generates electricity during the daylight only. In the evening there is no electricity generations. example. But on the other hand, when you are talking about new loads or new technologies like electric cars, it has an embedded batteries in it. So theoretically, we can actually utilize this battery somehow to generate the power balance in the system. I mean, many of you realize that electricity must be always in balance between supply and generation. That's why balancing the supply and demand is one of the issues. And photovoltaics is indeed fluctuating or intermittent in generating electricity, but again, technologies that batteries that including batteries which is already actively hydro, for example. Will it stop there? If you go to Industrial 4.0, where now everything is connected via internet, via data. So actually, the big enabler for this electricity next generation is actually in the technology, information technology and communication. Some people say smart grid, some people say smart power, but the key here, actually, especially if you are seeing countries like Indonesia, it often the drive for the fusion of new technologies is in the people. So imagine, maybe at the moment, for example, by regulation, it is still not easy or not practical, not easy basically, to purchase electricity from neighbors. But imagine, with internet technology and smart meters, technology is already there. Actually, we could simply put smart meters in every point of connection, either in the generation point or consumption point, where we are tracking what electricity generated and consumed. And then the next step, with all this big data, we already have the infrastructure and technology to communicate, to see who is paying what. So that is basically the enabler to make all the system work. We do have this technology for the renewable energy generation. We have different technologies, including electric vehicles and batteries embedded in it. And on top of that, we have this umbrella of information technology, internet, IoT, telecommunication, and so on. So, what would be the plausible impact? Why do you think it will not go faster in that direction? Actually, this next generation of electricity would affect plausibly the classical or conventional power plant. See the scenarios. On my right-hand side, assuming more and more customers are installing photovoltaic on their rooftop, households or commercials, what would happen? They will pay less electricity bill to the power company. So it goes to the left-hand graph here, which means the power company will get less revenue. With now, they are mostly generating electricity from a coal-based power plant. So revenue is decreased, but investment was there. So they still have to pay for the investment from day one. So if situation is blowing, to make this investment still attractive, they have to increase the electricity price or tariff. When the electricity price is increasing, it's becoming cheaper to get electricity from the PV, from the photovoltaics. So it means more people will buy the photovoltaics. And when people buy more photovoltaics, the manufacturer will be more efficient, economic of scale, so the price of PV will go even further. It means revenue to the right side is becoming lower, and it's going in that direction. So this is basically the possible impacts of this next generation of electricity. So whether it's a challenge or opportunities, it depends on how we see it. But just to conclude this presentation, basically I think most of us here are either engineers or practitioners in the field. So I personally see this more as a challenge, as an opportunity. It has certainly challenges, but I think we, especially the young generation, have to accept that the world has changed. That the technology for this PV is cheaper, is more affordable, and the young generation is also willing to try new technologies, and they are having a higher concern on environment. So what we need to do, like, we have to focus on the technical strategy, how this renewable energy generation can be implemented in the system seamlessly, which is stably, and one of the opportunities is basically a smart grid, which we don't need to be intimidated with the word. Actually, all the technologies are there. Smart meters are there, monitoring system are there, demand management system are there, the internet infrastructure are there. The only thing which is missing here is, in my opinion, was the business model. So how we can make a business model that tailor all these components, all this technology, that it can make a business model that survives. And we do have example in Indonesia. If you see this online transportations, online taxi and bike taxi were actually a result of tailoring all these different technologies with the right business models. And that's what we are waiting to make this electricity generation 4.0 is taking.